That's why I noticed there are more fans in those buildings
Right.
because of the heat factor.
Right.
The non-circulation of air.
Yeah. I mean, and we have to remember that these changes are really small.
What we looked at mainly were bathrooms because they're kind of the easier things to take actual numbers on. And we examined all the student bathrooms, and through calculations we assessed that over 1 million gallons a year are used in student bathrooms, and the actual numbers right there. And with the current rate, that's about that almost $4,000. So we got like a pediatric books that like gave us average values for the amount of time students use the bathrooms and stuff, and we did a bunch of calculations using the toilets and the urinals and the faucets. I mean, it's all a bunch of estimations, but they all seemed like pretty well in the ballpark. Like when I thought back when I was in high school, it's like, yeah, I wouldn't buy that much. But I mean, they're rough numbers, but they're pretty close. I mean, the only better way we could have done it is if we actually counted people going to and that's just kind of creepy. But they did that in Saunders Hall. Yeah.
We actually had laser counters that actually, like, we broke a laser and we got to count how many people used the bathrooms.
Pretty good.
Count whether or not they flush.
Yeah, that counts.
We assumed that there was 1 for 1, but who knows, right?
So what we found were Kalani's fixtures are low flush models that use 1.8 gallons per flush and 1 gallon per flush for urinals. The average for like non-low flush models is like 3 and 5, I think. And those are usually all over places. So that's pretty good. And the faucets have aerators, so they use less water. So that's a pretty good thing. Kalani is on the ball.
All right.
Oh yeah, there it zoomed in. And here's just an example of new technologies that are available. And we're just saying, like, you know, there's always a better model out there, and these are it. And these use 1/8 of a gallon per flush and 1.3 gallons per flush. They actually have like waterless models right now, but those are kind of use like a lot of maintenance. Like you need to know how to take care of them, or it'll like stab you in the back.
Oh, I see.
They have them at like Manoa Park, I think, and they have a janitor come every day, and he's pretty familiar with it. And the ones over there are pretty good. So yeah, they can work, but it's a lot on like your janitors. So these are a lot easier to use. And based on the numbers we actually got from Sustainable Saunders with the counters, it turns out that something 80% of people that like go into the bathroom instantly go to the nearest toilet or urinal. So if you were to switch out a toilet or urinal in your bathroom, if you went for the nearest toilet or urinal, you'd get 80% of the people for one fixture. So when we looked at our strategies to replacing urinals and toilets, we went with all of them and just the closest ones, since just the closest would hit almost all the people.
Is that for women and men?
Yeah.
Oh.
And if you think about it, I do that too, most of the time. If it's a dirty bathroom, I'll run to the end. But yeah, I'm pretty lazy.
It is actually good to note that it wouldn't be the exact same for every single bathroom, but the bathrooms here and the bathrooms in Saunders are actually set up very similarly in configuration. So if I was doing this, you know, if you were going to do this for every school, I would make sure I'd look at it and say, well, there's 3 here and there's 3 here. It's lined up in the same way, but it might be slightly different if all of the urinals at the back of the room, or you have to cross the room, it might be, you know, but then it would be encouraging to get laser counters at that point and see which one. I pretty much guaranteed one of them is going to be higher, probably in the 80% range. In bathrooms configured like this, it's the closest one, and other bathrooms might be slightly different, but it'd be worth the experiment, and then you don't have to buy new urinals for everything, just the one that has the biggest bang for the buck. Yeah.
And here's just water usages of our strategies and the current. So the blue is the current water usage. The red bar is if we switched every single toilet with better models, and the green is just the first toilet to urinals in every single bathroom. And you can see that the green and red are pretty close to each other. And this is just projected annual savings. So if you don't do anything, it's 0. But if you switch it, it'll be $1,300 per year and $1,000 per year. Water's kind of skewed because it's like kind of cheaper compared to electricity. But if you think about it, these are all in terms of like 1,000 gallons per year, and so even though you're not saving that much money to say, you're saving a lot of water, which is a lot about.
Not only our sewers tight.
Mm-hmm.
Oh yeah.
Yeah.
It's in fact, it is, right? It's
Yeah,
like-
that sounds based on that, but it all costs to flush.
And we did a
Return on investment.
yeah. My bad. I'm taking an engineering econ class and I keep on seeing interest everywhere. But yeah, if we replace everything, the payback period is about 6 years with those projected costs. But if you just did the closest, it's 1 year and 8 months. So it's almost like a third of it. And you saw that the actual changes weren't that far off.
Does that cost include labor or is it the fixture only?
No, just fixtures.
Picture only. Only because we had to buy them at Saunders, but the facilities put them in as part of within internal.
And bathroom water usage isn't really that big. It probably like one of the main components along with cafeteria and irrigation. For the cafeteria, we just assumed a standard water usage that we found on like a study on different schools, and then we minus that and the bathroom usages out of the current water bill for a year, and we figured that 2.5 million gallons are possibly used for irrigation purposes. So finding better ways to irrigate would have a much higher impact on Kalani. And it's loading for some reason. Okay. And we saw that currently the football field's irrigated on a timer right now. And I actually couldn't talk to the athletic director that bought the timer because our schedules didn't match up. But I know one day we were here during the summer and it was watering the field at like 1 p.m. Yeah, something like that. Like at high noon, basically. It was really hot. Yeah, I would have liked to talk to him about the timer, but we don't know that information.
Actually, it's not on a timer.
Oh, it's just whenever.
It's manual.
Oh.
It's manual because of the fact that the use of the field at different times of the day, they don't want wet fields, so it's not on every day. So I think at the time that you were probably taking.
They probably had like a
Yeah, they
game
were.
at the night or something.
Yeah, or there was soccer practice or some kind of practice.
Oh, I
where-
see.
Yeah, so generally they don't want a wet field.
Oh well, yeah,
So,
manuals
Yeah.
way better
Yeah.
because then it's easier to regulate this. So what we'd say is just to not water between 9 and 3 because a study showed that 80% of the water you use is evaporated, and it's actually healthier for plants to water more often with less water. Oh yeah, so for the field it's watered by sprinklers, but the rest of the school it's janitors just walking around with little hose sprinklers and they just water as they see.
On your third bullet there, that's interesting because I've seen elsewhere that if you have X gallons per acre to apply, you're better off applying it twice a week than 1/7 every day, because if you do 1/7 every day, the root system adapts to that and won't go down, and it then requires it's less drought tolerant.
No, that's cool.
And it would be interesting to.
Maybe it depends on like the type of plant.
Certainly could depend on the plant.
Yeah.
There's probably that fine balance, right?
Yeah.
Yeah. Yeah.
A little water every day, my other understanding was a little water every day is not all that good for the plant.
Oh, interesting.
The same amount of water, but applied more per application less frequently,
Huh.
gives you a stronger plant.
Interesting.
Currently, I think the janitor told me they water the school once a week with the stuff.
I wouldn't die.
Yeah. So maybe that's a fine balance. Maybe compared to that, it needs to be more often.
Although
not every
now
day.
it's more often because of
Yeah.
the current administrator would like it to be more green, so there's more watering going on.
So yeah, I mean, we couldn't really estimate numbers
Yeah,
for
so
these, but
it's changing.
What do you want in the hillside?
They're watering in front of the administration, so all the hills is accessible, that viewable to the public is where he's watering
The one
more.
downside of the manual watering, it's the optimum time to
Exactly,
do it
so
would be
from
evening
9
Yeah.
o'clock to 12.
when nobody's here.
Yeah. Yeah.
Late night, early morning.
Yeah.
Yeah.
This is just showing like the bigger impact irrigation could have. If you remember, our possible savings from changing the toilets was about 1,000 a year. If we could fix like possible like irrigation problems and stuff, like just not water during the day, the money we could save would be almost $8,000, which is, you know, a lot more than the bathroom. So fixing problems with our irrigation is a lot more impactful than fixing waters and fixing stuff with the bathrooms. And the bathrooms are already pretty good. They have low flush models. I mean, you can't really ask more out of them.
Would the swimming pool have an impact on this? Did they drain them water or change it on?
I didn't ask much, but Roosevelt drained pool like maybe once a year when I was
Same
there.
here.
Roosevelt.
Once a year.
What's your
Once a year.